Hi, welcome to a two-part series on finding the missing angle. We're going to be finding angles within triangles, and we're going to be finding angles outside of triangles using our information about alternate interior, straight angles, and the like. So let's start out with a very straightforward problem. Now, I'd also like to remind everybody that this is meant to be done in sort of a Cornell note style, so I'm going to write a question and then that would be on the left-hand side of your piece of paper as you were doing it, and then all your work would be on the right. Mine's all going to be on this whiteboard here, which, again, remember you can always stop, rewind, pause, check it again. So we have ourselves our little old triangle here, and if we know two of the measurements of the angles, we can find the missing angle pretty straightforward, pretty simplistically. So this would be what is the missing angle. Okay, so we're going to be trying to figure out a missing angle within the confines of a triangle. So this starts out with, what do we know about triangles and can we use it? Well, every triangle is 180 degrees. We know that. We saw that in our last lesson, and if we don't, we got to remember it. Triangles is always going to be 180 degrees. So that means that all three of these angles have to add up to it. So we have a 50-degree angle, we have a 60-degree angle, we have the unknown, and then we know the total. Okay, that's a pretty simple equation for us. We simplify this. 110 degrees is what the other two angles are. And then we subtract that from our 180 degrees. And that tells us that our missing angle is 70 degrees. Now, maybe I didn't draw it that perfectly. Of course, I didn't break out a protractor, so that's certainly not going to happen. But this gives us an idea of what kind of problems we'll be confronted with in the future. Now, this is probably the simplest of them because triangles are very straightforward. And if we know two of the missing angles, we can certainly find the third because we know the total. But we may find ourselves with a variety of different ways to present the same information. So I'm going to be showing you a few of those right now. And then in the second part, which I'll do a second video for, you'll be seeing even some more creative and maybe more challenging ways to deliver this same piece of information. So this was our initial volley, our first question. Now this second one, I'm going to be looking for two angles here. So we'll start out with the question, what are the missing angles? And we're going to use that plural because we're looking for two. And this is where we're really going to do something interesting. Okay? We're going to think outside the box, as it were. Because inside the triangle, we're going to look for this value, y. We're also going to be looking for this value x. Now I need one more piece of information that's going to make this something that we can do, and that is this outside the box question. And that is that angle. So now we're going to have to use that information to find x, then we'll use that information to find y. So this becomes a two-part process. Obviously there's two questions, but you have to do it, in this case, you actually have to do it in order, because if you try to do y first, you find, hey, I don't have enough information. I only know one of my angles, and I don't know the other. So let's start out with the x part. What does this x value represent? Well, it represents the interior angle of this triangle right here. And if we look at it, if we take it out of the triangle for a moment, it looks like this. And then just outside of that, we have this 130-degree angle. Now, what have we got here? We've got ourselves a straight line. If we remember from our previous lesson, a straight line is also called a straight angle. And a straight angle, much like a triangle, equals 180 degrees. So a straight angle is also 180 degrees. So when we have those two pieces of information, now we're in a position to find x, just like we did with y, and even more simplistically, because we have x plus the other side of that and that's 180 degrees. Here's my straight line, cut into two angles, this one and this one. Subtract the 130, and my x equals 50 degrees. So now I know that this is 50 degrees. And now I'm ready to find y. Well, this should look very familiar. We just did it actually, because if x is 50 degrees, and this angle is 60 degrees, and I know I'm writing downward now, and we're missing y, we're back to what we had in the previous problem. So we know that y is 70 degrees, because we know we got from what's outside the box to what's inside the box. Now some of you might have noticed something interesting here is that if y is 70 degrees, then these two angles had to add up to 130. So you actually could have found y on its own. You could have said y plus 60 equal 130. Now why is that? That's because this angle and this angle were part of a straight angle and therefore had to add up 180. And that these two angles plus that same x also had to add up to 180. So if this plus this was 180, and these plus this were 180, well then these had to equal this. They have to. It's the way that things have to play out. Okay? I'm going to erase, so if you wanted to write this down, remember you can always go back and pick it up. So I have one more example for this lesson. Okay, and again it involves a straight angle or a straight line that's cut into two pieces. Okay, this cutting piece is called a transversal, and now we have two angles. We have this one and we have this one, and together they have to add up to 180. Now I know that this angle is 50 degrees. This one, on the other hand, is got a strange measurement, 2x minus 6. This is what I'm talking about by getting more and more complicated. Instead of just always being, here's the numbers, figure it out, what if we start to throw variables into this? Okay, this would be that first example of that. But you know what? We've done this, same thing, just a little more complicated. That's what we do. We get slightly more challenging. So now we know that it's 50 degrees plus 2x minus 6 degrees still equals 180 degrees. This is still two angles, still add up to 180. They're still supplementary, if you remember that vocabulary from last week. And now we're going to solve for x. We're still going to simplify. We're going to go 50 minus 6x, that's 44. We're going to have the adds 2x. And now we're solving a multi-step equation. We're going to subtract 44 from both sides. And we're going to divide it by 2. And x equals 68. Now remember, that's not the measure of the angle. That's the measure, that's the value of x. The measure of the angle is 130 degrees. We knew that because we saw it from the previous problem. These have to add up to 180. Okay, but this is the value that will make the angle be 130 degrees. X is 68. That will give us the right measurement. Okay, now when you're finding your missing angles, obviously you always want to go through these as methodically as you can. The more you do this, the easier it will become and the faster you'll get at it. Okay? Again, I look forward to seeing you all in office hours if you need it. Until next time.